In this tutorial, we will talk about expressions in Java. We will cover arithmetic operators, order of operations, data conversions, how to change data into another type called casting, and how to create an algorithm for rounding. Here are the arithmetic operators and symbols we can use when creating arithmetic expressions. The remainder operator may be new to you. This is also called the mod operator and is denoted with the percentage symbol. This operator calculates the remainder when division is performed. 4 mod 3 calculates the remainder when 4 is divided by 3. Recall that 3 goes into 4 one time. 1 times 3 is 3. 3 is subtracted from 4, and the result is 1. 1 is the remainder of 4 divided by 3. So 4 mod 3 is 1. Let's try another. 8 mod 13 calculates the remainder when 8 is divided by 13. 13 goes into 8 0 times. 0 times 13 is 0. Subtract 0 from 8 to find the remainder of 8. So 8 mod 13 is 8. When you evaluate an expression in Java, the results will be different when using integers or doubles. If both operands are integers, then the result is an integer. If one of the operands is a double or contains a decimal, then the result will be a double. This is where it gets tricky. Both operands are integers in this division expression. I call this integer math. The result will be an integer. We know 6 divided by 4 is actually 1.5, but in Java, since both are integers, the result must be an integer. Any decimal portion is truncated. This is really important to remember. The result will not be rounded up. Even if the result was 1.9999, if both operands are integers, the result will be 1. If one of the operands is a double, then the result will contain the decimal portion of the answer. Order of operations is what you are used to. Evaluation is from left to right. Parentheses are evaluated first. Multiplication, division, and the mod operator have equal precedence and are evaluated before addition and subtraction. In this example, 2 times 3 is evaluated first for a result of 6. 6 divided by 4, since both of the operands are integers, the result is 1. The decimal portion is truncated. 1 plus 6 is 7. In this example, 2 times 4 is 8. Since both operands are integers, the result is integer 8. Integer 8 divided by integer 3 is 2. In this example, 2 times 4.0 results in 8.0, a double. 8.0 divided by 3, since one of the operands is a double, the decimal portion will not be truncated, and the result is 2.66 repeating. We can convert ints to doubles and doubles to ints by casting the data to look like a different type. Casting an int to a double is called widening. We are adding more precision. Casting from a double to an int is called narrowing. The decimal portion will be truncated, not rounded. Be careful when using this type of conversion because you will lose precision. This statement creates an int variable x and assigns the value 3 to it. This statement tries to assign the double value 4.7 to the int variable x. Since doubles are 64 bits long and ints are only 32 bits long, this will not work and you will get a compile error. Think of variables as cups, a double being 64 ounces and an int being 32 ounces. If you pour the contents of the double into the int, you will lose part of the data. If we don't care about losing precision, we can force Java to truncate the decimal portion by casting the double to look like an int. The resulting int can then be assigned to the variable x. In this example, 4.7 is truncated to 4, and 4 is assigned to the variable x. In this example, y is created to hold double values. 3.7 is assigned to y. We can assign int values to double variables without casting the int to look like a double. This is called an assignment conversion. Java converts the int to a double before assigning it to the variable y. Let's look at casting in detail. The results will be different depending on where you cast the data. In this example, we create a variable called result, which will contain double values. In this statement, I'm going to cast 10 as a double and then divide by integer 4. Note that the casting of double is right next to the value 10. Integer 10 is casted to look like a double, which is divided by 4. The result 2.5 is placed into the variable result. Remember, the expression on the right is evaluated first and the results are put into the variable on the left. Now watch what happens when I cast in a different place. Again, result is created, and since I have parentheses around the 10 divided by 4, that is evaluated first. So 10 divided by 4, since they're both ints, the result is 2. Integer math is occurring and the decimal portion is truncated. After the division occurs, then I will cast the result to look like a double. So 2 is converted to a double, which is then placed in the variable result. So be careful when you're casting. Make sure you are placing the cast in the proper position. Here's an algorithm for rounding decimal values that you should know. In this statement, we create a double variable called x and assign the value 14.7 to it. In this statement, I create an int variable called result, and then the expression on the right is evaluated and placed into the variable on the left. In the expression, I'll be using the variable x. When the expression is evaluated, I will be using the value 14.7 for x. 14.7 plus 0.5 is 15.2. That decimal value is casted to look like an int, and the resulting 15 is stored in the variable result. In this tutorial, we learned about the arithmetic operators you can use when writing Java programs. We learned about order of operations, data conversions, casting, and an algorithm for rounding decimal values.